So one final example of being able to utilize the set laws to be able to work with these types of problems is going to be illustrated here. So we have this a minus b minus c is equal to a minus b. All right. So hopefully you tried to attempt this. If you haven't tried to attempt this yet, or maybe you didn't know where to start, maybe pause it, try to work through it, okay, see how far you can get with it. So first thing we always do, set difference law. Okay, so if I was to do this, we say that this becomes A intersect B complement intersect B intersect C complement complement. Okay, so that's our set difference. Now, we always want to use set difference, and then probably the next thing that we want to try to utilize is the De Morgan's property. Okay, so if you ever have a complement on the outside of parentheses, De Morgan's law is probably going to be very helpful. Okay, so we're going to keep that A intersect B complement intersect B complement. With De Morgan's, you flip the quantifier over, and we have C complement complement. Okay, and I'll just write it under here that is De Morgan's law. The next thing we probably want to do is we probably want to utilize the double negation property, all right, or double complement law in this case. So our double complement law is just going to say that if we have two of the same complements, they just cancel each other out. All right, so this is going to become, we're going to still have that A intersect B complement. Then we're going to have intersect B complement union C. Okay, that's our set difference. Or I'm sorry, our double negative law. Excuse me. So that's a double complement law. All right. Now at this point, we're kind of stuck. And the reason we're stuck is because we notice that, first of all of the quantifiers are not the same, so we can't utilize commutative and associative laws. And we also notice that we can't necessarily use an absorption law at this point, all right, just because we don't have the same sort of, we don't have the same sets exactly going on. So the only thing to do at this point is to utilize the distributive property. And what we're going to do is we're going to distribute to both this A intersect B complement. We're going to distribute it to both B complement as well as C complement. All right, so it's going to get a little bit ugly, but it's okay. We're just going to take our time with it. We're going to make sure that we distribute well. All right, so we're going to end up with A intersect B complement intersect B complement. And I'm going to use brackets. Excuse me. Union A intersect B complement intersect C. All right, so that's our distributive property. All right, the second set of parentheses we can't really do much with. Okay, so right here, the only thing we could do is we could use an associative law. Unfortunately, that's not going to help us too much. However, in the first set of parentheses, the associative law will help us a little bit with that one. All right, so I'm just going to use the associative law. I'm going to bump over those parentheses. So we're going to get A intersect B complement intersect B complement. So notice we just move the parentheses. And then union A intersect B complement intersect C. Okay, and that's just our associative law. At this point, we notice that we have the exact same thing twice. We have B complement and B complement. Logically, that tells us that we just have B complement, and that's going to be true by our idempotent law. Okay, so look down the list, and you can see that this is now going to become, in fact, I'm going to rewrite this. And we just have A intersect B complement. Okay, so again, that's just our idempotent law. I'm going to put that in parentheses. Union A intersect B complement intersects C. Okay, so idempotent. Finally, we're at the point to where we can get rid of some stuff, because I want you to notice that we now have two of the exact same set. So we have A intersect B complement, A intersect B complement. Now think of this in the form. So the form that we have, if this is set A, and think of C as set B, then we have something of the form A or A intersect B. Right? So that's the discrete form that we have, or the structure that we're looking at. Well, I want you to notice that the absorption property actually follows that law. Okay, so the absorption law says that if we have A union A intersect B, that just turns into A in this case. Now, for us, we don't have A, we have A intersect B complement. All right, so we're going to rewrite this now by the absorption law as A intersect B complement. Right, and then the last thing we need to do is we just need to use a set difference law on this one. And we're done. And notice that it looks exactly the same as the right-hand side that we wanted. So, a little bit sneaky with this one. So I would recommend that go back through, make sure all the steps make sense, and if they don't, make sure you contact me to try to get a little bit of help with this.